Hello there, welcome back. Today we're just going to speed run some of these blind 75 Leetcode problems. I've opened up a fresh Leetcode account which I think has 0 problems solved, so we should be able to solve all of these without running into any ones that we've already done. So yeah, you can find this at neetcode.io/practice. And I'm basically just going to be probably working for like 15-20 minutes and just seeing how many of these I can get through, and also just walking through my thought process while I solve them. So here we go. Let's open all of them up. And first we'll start with contains duplicate. So given an integer array nums, return true if any value appears at least twice in the array, and false if every element is distinct. So something I think we can do is use a hash map, right? Where our key, if you're not familiar with the hash map, it's a key value pair, a table of key value pairs. So our key will be like the element or the number in this list. So here it would be 1, and the value would be how many times we've seen it so far. So what we're going to do is we're just going to walk through this. If the number we're at isn't already in the hash map, we'll add it to it and then continue. And if at any point we see a number that's already in the hash map, then we'll just return true, because we've seen it before, and that means not every element is distinct. Otherwise, if we reach the end of the array and we haven't hit that condition, then we'll just return false at the end. So we'll just say return false, and we'll say for num in nums, if num not in mapping. So if the number is not in our hash map, then we'll say mapping of num is equal to 1. Otherwise, if num in mapping, we can just return true. Right? So we're walking through the list, the number in this numbers list. If it's not already in the hash map, we add it to it. Otherwise, if the number we're at is already in the hash map, we know it's a duplicate. Okay, looks like all 3 test cases got accepted, so let's submit. Okay, there we go. Awesome. Okay, next problem. Is anagram given 2 strings s and t, return true if t is an anagram of s and false otherwise. So basically an anagram is basically 2 words that have the same letters, and those same letters occur the same number of times. So here in both words, a appears 3 times, n appears once, g appears once, and so on. If, for example, S had 3 or 4 A's and T only had 3, then it would not be an anagram, because they need to have the same characters, and each character also has to occur the same number of times. So I think an easy way to do this is, again, a hash map. So this time our key will be the character, and the value will be the number of times that character occurs. And then what we can do is we can go through and make sure that, first of all, no character that's in S is not in T, and vice versa. And also, if those conditions pass, make sure that the count of each character is the same as well. Okay? So we're going to import a helpful tool here. It's just going to save us a few lines of code. And this will give us a hash map that contains all the characters in both of these strings and the number of times they occur. So I'll say smap is equal to counter of s, tmap is equal to counter of t. And just to show you what our counters will look like as hash maps, I'll just print them out for you. It's going to say wrong answer, but that's because we're not returning anything yet. So you can see that we have our counters, where the character A appears three times in both S and T, N appears once, G appears once, R appears once, and M appears once. Okay? So now that we have the counters, right? First of all, we want to make sure that each character that's in both occurs the same number of times, and that there's not any character that appears in one that's not in the other. So we can say svals is equal to smap dot keys. I believe that's the method. And let's call this schars to represent the chars that are in the S string. And tchars is equal to tmap.keys. And just to make sure that this is actually a method, I'm going to run this again. Okay? So standard out, ANGRM. Okay. So then what we need to do is we need to say for ch, which stands for character in schars, if character not in tchars, return false, and then we need to do the same thing the other way. For character in tchars, if character not in schars, return false. Okay? And then the reason we're doing this first is so that we can then do this next check without worrying about an edge case. So let's say for key value in schars.items, if val is not equal to tchars of key, return false. Okay? And if none of these conditions occur, this should then return true. So again, we're creating counters which count the number of times each of these characters appear in both of these strings. Then we're looping through the characters in both these strings and making sure that none of them have a character that doesn't occur in the other. And then we're going through, once we know that they don't have differing characters, then we're just going through and checking the counts of the characters in those hash maps and making sure that they're all the same. So now let's run this. Okay, getting a runtime error. There's no attribute. Oh, this should be smap. Okay. Snap the items if val does not equal to tchars. Dict keys object is not subscriptable. Oh, that's because again this should be tmap. Okay, we should be good. There we go. We passed both test cases. Let's submit. Okay, there we go. On to Twosome. The goal of this problem is given an array of numbers. Find out if each input is always going to have exactly one solution. Return the indexes in the list of the two numbers that add up to a target. So we're given a target of 9, right? So the numbers in this array that add up to 9 are 2 and 7, right? So we return the indexes of those two numbers, index 0, which is 2, and index 1, which is 7. Okay. Now there's a few solutions to this. One of them is we can look at every possible pair of numbers. We can look at like 2 and 7, then 2 and 11, then 2 and 15, and then we can look at 7 and 11, and 7 and 15. That's really inefficient. So again, we're going to throw a hash map at this, and we're going to say mapping, okay? And we're going to use the target to our advantage, right? So we can do this looping through this list just once. So we'll start here, okay? And we're going to add this to our hash map, right? Okay, and then we're going to say, is there a value in our hash map such that 2 minus the target exists? Is there like a -7 in there? No, right? Then we come to 7, right? And we say, okay, what's 9 minus 7? 2. Is there a 2 in our hash map? Yes, right? So then we found our answer. So we're going to say, for num in nums, if num not in mapping, mapping of num is equal to and we want the index of that number, right? So we're going to use some Pythonic stuff here. Okay? And then, like I said, we're going to use the target to our advantage. So we're going to find the complement. Complement is equal to target minus num. So once we hit the 7, target minus num, our complement is going to be 2, and we're going to check, is there a 2 in the hash map, right? If complement in mapping, right? If 2 is in the mapping, return a list of mapping of complement, right? That I value that we stored here when we were at 2, comma, whatever the index is that we're currently at, right? And we know that there's always going to be a solution. So I think this should be good. So we're going through the numbers array. If the complement is in mapping, right? If we know that other value that we need is in our hash map, we just return the indexes that we stored in the hash map and then the index that we're currently at. Otherwise, we add the index of our number to the hash map. Okay. There we go. Looks like we're passing all 3 test cases. And this is the 1-pass hash map solution. There is a 2-pass, but it's less efficient. Okay, that was accepted. Let's move on to group anagrams. So, given an array of strings, group the anagrams together. We can return the answer in any order. And again, as we talked about, an anagram is just 2 strings or 2 words that have the same characters, and all the characters occur the same number of times in both strings. Okay? So here's what I think we're going to do. Again, we're going to use a hash map. And this is kind of interesting. So what we're going to do, right, is we know that an anagram, first of all, has the same characters, and each character occurs the same number of times. So what we can do is, as we're passing through, we can sort each word alphabetically, right? So this becomes AET. And then we get here, and this sorted is also AET. So we're going to use the sorted version of the word as we're passing through as the key in our dictionary, or our hash map. And then the value is going to be each word that has that same sorted value. Okay? Hopefully that makes sense. So we're going to create a map for string, for word in strings. Key is equal to, and like I said, it's going to be the word dot sort. Okay? And let me make sure that's right. Sort string alphabetically. There's got to be a better way than that. That was in 2013. Okay, so let's just do it this way. Okay, we'll come back to this. The key is equal to the sorted word. Okay? And then we want to check, do we have this key in our hash map already? If key in mapping, actually let's do this the other way. If key not in mapping, mapping of key is equal to, and then we're going to put a word inside of an array, right? Because our output's a nested list, and each nested list is all the words that are anagrams with each other, right? So the first time that we put something at a particular key, we want it to be a list, so then we can add the future words to that particular dictionary key. Okay? Elif key in mapping. I could just have an else, but I like to be specific. And we're going to say mapping key dot append word. Okay? Okay, and then we can have a results array for val in mapping.values. Then we're going to go to the dictionary we've constructed, and we're just going to add each value, which is going to be those dictionary key lists, to our result array. res.append val, and then we can just return res. And I think that's enough. Okay, so it looks like we passed all 3 test cases, and you can see our output is a nested list, and everything in a particular nested list is an anagram of each other. Okay, let's submit. Okay, that was accepted.